Okay, let's finish up. We did 2-6 the other day, and we're just going to basically take everything we learned with these asymptotes, and we're going to put them on graphs. Okay, so go ahead and tell me my vertical asymptotes, holes, horizontal asymptotes, oblique asymptote if they exist, anything you can remember. All right, so we cannot simplify this any further, meaning we cannot factor it and whatnot. So automatically, my vertical asymptotes, I look at my denominator, so x equals 3. Horizontal asymptote, who wins? If the denominator wins or the bottom wins, what is it? Just y equals 0. Yo at the bottom. Okay. Do we have any holes in our graph? Nope. And since we had a horizontal asymptote, do we have an oblique asymptote? No. Yeah. Okay. So this is what we know so far. So at x equals 3, I have a vertical asymptote. At y equals 0, I have a horizontal asymptote.
This is giving me flashbacks.
Huh?
Flashbacks from Algebra 2.
Is it?
Yes.
Like bad ones?
Yep.
Let me know if I change your mind.
That'll happen.
Well, positive is all.
So,
Not that I'm.
if we want to make an entire fraction 0, what would have to be set equal to 0?
The top.
The top. Okay?
Good answer.
The numerator. If just the numerator is 0, then the entire fraction becomes 0 because you do 0 divided by something. Okay? Well, if we want the entire fraction to be 0, another way to say that is y equals 0. Okay? So in that case, that's how we're going to find our x-intercepts. All right, so in other words, you might want to put, because this wasn't on our notes from before, but our x-intercepts are going to come by setting our numerator equal to 0. Well, in this case, our numerator is 2, so in this particular case, we are not going to cross the x-axis. There's nothing to solve for if it's just 2.
Is it always like that if there's a horizontal asymptote that's 0?
No, because remember the horizontal asymptotes you can cross, and they're going to be at x-intercepts. Now, vertical asymptotes are actual restrictions on the domain, things you cannot do. Horizontal asymptotes are kind of like guidelines. So they're not like, no, you can't be here. It's more like, this is like where you'll kind of go. So you can cross a horizontal asymptote, and usually it happens on an x-intercept. Okay? All right, a y-intercept is when x equals what? When you cross the y-axis, what does x equal? 0. Okay? If I plug in 0, what do I get?
Negative 2/3.
Negative 2/3. So at 0, negative 2/3. Okay? Now, some teachers will teach symmetry when it comes to these problems. Okay? Me personally, I kind of take it the same approach as we do quadratics, where we start plugging in numbers to find our additional points. So, for instance, let's take an x value. Let's plug in x equals 1. Okay? Just because I want to see what this graph ends up looking like. So I'm going to take x equals 1. So that's 2 over negative 2. So then I know at 1, I'm at negative 1. I could plug in 2 if I wanted to. 2 minus 3 gets me a negative 1. So I get negative 2. So once you have a good idea of what it's going to look like in this area, you can stop plugging in points. Okay? Now, a couple of different options of where it could be next. Okay? Can it be up here?
No,
Why?
because of the horizontal asymptote.
But like up here away from the horizontal
It
asymptote.
wouldn't be, it should be like mirrored across
It's
the,
a function.
whatever.
It's a hyperbole.
If it's supposed to be a rational function, it has to pass the vertical line test. And if a line or a graph was up here, it failed the vertical line test. Okay? So it could be either up here in this top right corner, or it could be down here. Okay? So in other words, I need to know what happens on this side over here. So I'm probably going to pick 4 to plug in. So if I pick 4, I get 2 over 4 minus 3. I get 2 over 1. So at 4, I'm at 2. If I wanted to plug in 5, I could. 5 minus 3 is 2. 2 over 2 is 1. So now again, I see that my graph's going to be up here.
Do we always have to do this by hand?
I think there's one on the calculator portion of the test. But yes, it is by hand. Algebra 2 is probably in the calculator. Okay, questions so far? We're just going to do a bunch of examples like this to make sure we know how to graph them. Okay. Go ahead and write out all my details here. Vertical asymptotes, holes, horizontal asymptotes, oblique asymptotes. x-intercepts, y-intercepts. All right, so let's see what we know so far. We know our vertical asymptote is going to be at 1. Even though there's 2 of them, we just are at 1. Do we have any holes in our graph? No. Who has the highest degree? Who has the highest degree? Bottom. So yo at the bottom, y equals 0. X-intercepts. Again, we just have 1 up there. Literally the number 1, so none. We don't have any holes. And we don't have any oblique asymptotes. Again, you don't have to write that if they're not asking for that, or if basically I just want you to get in the habit of if there is a spot for it that you put none. Okay. Y-intercept. If I plug in 0 for x, what do I get?
You get 1.
I said it.
I said it.
Multiple times,
So 0, 1. So we kind of have an idea that this one's going to go like this. Okay, they're always going to ride along the asymptotes. Okay, get really, really close to them, but not cross them. The fact that I don't have an x-intercept, I'm not going to cross this one here. So I can kind of go ahead and draw this one out. So this one can either be up here or down here. Okay, so if we need to figure out where that's going to be, I'm going to plug in 2, because that's the next side of that vertical asymptote, into the equation. 2 minus 1 squared gets me 1 over 1, which is just 1. So this one is right next to it.
What was that one called? Is it still hyperbole or is
These are all still rational functions.
it? Okay. So
No one gets a hyperbolus.
well, yeah, but I know it's just like what's the shape.
Hyperbolas are going to have these shapes. That's when you take an ellipse that goes like this, and it turns out.
So I know normally you say you won't count the graphs unless there are 3 points, but
I'm good with at least one valid point on each side. As long as you get the gist of where the shape is, then I'm good with that. Especially with these. If we get into, which we will, you'll want to do more points just because it gets a little bit more different in between. You'll see here in a second. Okay? Go ahead and give me all the details here. Bless you. Bless you. so with this one, we have a factor. What are two factors that multiply to get -6 that add to get 1? Okay, so still nothing cancels out, so we don't have any holes. All right, vertical asymptote, we now have 2. So this is when things get a little bit more difficult because inside those two, you can either have a cubic function go through it, or you can have a parabola. All right. You're still going to have your outsides that look like the other graphs that we've been looking at. So at -3 and +2. All right, horizontal asymptote, who has the highest degree? Bottom, you at the bottom. Okay. So now we do actually have an x-intercept. What's that going to be? -4. That's what I said. There are some cases where we are going to cross through a horizontal asymptote, and that is that particular case. Our y-intercept, we plug in 0 for x. We get -4/6, which ends up being -2/3. Okay. So, looking at the left-hand side, I don't know if it starts up here and slightly goes below this horizontal asymptote, or does it go like that? Whoops, I wasn't supposed to write. So that's why we're going to check another point. So if this is -4, I'm going to plug in -5 into the equation. And remember, I'm not using a calculator because if I could use a calculator, I would just go to y equals and I'd look at my table. All right. So from here, I get -1 over 25 minus 5, which is 20, minus 6 gets me 14. So -1 over 14. Somewhere down in there. So now you kind of see that it's going to start from up top and come down from there. Just slightly, nothing crazy. You could keep going if you wanted to plug in more values, by all means. So notice how I said I did not have another x-intercept. The numerator would tell me all the x-intercepts I'm going to have, not the imaginary ones, but it's going to tell me, well, it will tell me all those too. But it only told me that I crossed at -4. So I'm not going to go and actually do a cubic graph through here because that would require me to cross through the x-axis again. So this one's going to be more of like a parabola shape in the middle. All right. And again, if you plugged in more values, you would actually see that. So let's say I plug in -1. So I get 3 over 1 minus 1, which is 0, over -6. So -1/2. So we're just going to kind of hang out. It looks like a really awkward parabola inside there. If you plugged in more points, made them really accurate and all that stuff. But again, it just kind of hangs out in here for a little bit, and you have like I said, a weird parabola shape thing in there. Yeah.
Wouldn't it be? But how do you know if it's going down or up right there?
Like, if it went up. So I would have another x-intercept, and I only have one at -4. So like, I can't force an x-intercept to happen. So knowing that I can't cross this part right here tells me I'm gonna stay within there. Okay, and then let's say I plug in 3. I have a space over there. So if I plug in 3, I get 7 over 12 minus 6, which is 6, so a little bit above 1. So then I can go ahead and graph the rest of this. Okay, so like I said, within a middle part, like if we have 2 vertical asymptotes, you could potentially see a parabola in the middle, or you could potentially see a cubic graph, okay? And then knowing that when I cross the x-axis will tell you the difference between the two, right? Any questions on that one? Trying to make sure y'all see all the different types of these graphs. Okay. Let's check this one out. Don't worry, we only have 2 more. This one and 1 more. Who remembers how to factor that numerator?
I know the first part is, like, the first part would just be x minus 1, but then it would be like a whole trinomial.
Uh-huh.
I just don't remember the exact.
Look how much you remember.
I remember this.
Is it SOAP?
SOAP formula.
Same, opposite, always positive.
Yep. So if I have x cubed minus 1 cubed, yes, I have a shorter set of parentheses and I have a longer set. So I'd have the x and the 1. I square the first one, multiply the 2 together, and square the last one. Okay? That's just a weird way I would always say it, but there's like an actual formula that I'll write down for you. So what we're referring to is the same sign, opposite sign, always positive. So the same sign that you see over here, opposite sign, always positive. So this would just factor x minus 1, x squared plus x plus 1.
Pretty sure there was one like this in our homework.
Was there?
I think so.
Oh, here's that formula. A cubed minus b cubed, a minus b, a squared plus a times b plus b squared. Oh, I way out of space. And then it would be the same but different signs if you had a plus sign instead of a minus sign. Now, the good news about if you have to factor sum and difference of cubes is that the second part, you always have to do quadratic formula to find that answer, zeros there. But more times than not, they're going to be imaginary. So you don't even have to worry. In this particular case, you don't even have to worry about doing the quadratic formula here to find your actual zeros because those are going to be imaginary. the highest degree? Numerator. No way, top can't win. So none. Are we 1 degree apart?
Yeah, but you can see the other.
So there's no oblique asymptote. Remember, we find that by doing long division. But we do not worry about the remainder. We should just get y equals x. Our x-intercept is just going to be 1, 0. Like I said, the other one is going to be imaginary. And our y-intercept is going to be 1, 9. So that's what I just needed y'all to do, was just all the details. Graphing we're going to do together. Because we have not done a slant asymptote yet. So we have our verticals. And our oblique asymptote, we are going to graph like a normal line. Okay, my y-intercept is 0, my slope is 1 over 1. So technically I'm just going to cut it in half like this. It is also my identity, linear identity function. We cross the x-axis at 1, 0. And our y-intercept is 0, 1, 9. Oblique asymptote, just like a horizontal asymptote, is one you can cross. Okay? Vertical asymptotes are the only ones that are the big no-nos. They're domain restrictions and all that. See if you can plug in points to see how this graph is going to look. Sorry.
There is someone on the board.
Yes, ma'am.
Yes, that needs to be covered. Yeah, I do. Okay. I'll do it.
Does your clock work?
Yes, not mine, like the math one, but the other one, yeah.
What do you mean, the math one?
There's math one that just said.
Oh, so the school clock works?
Yes.
Okay. Sorry, I was.
Thanks, Denny.
Sorry, I just found that out yesterday. I'm not worried about that.
I can flip some of that trig stuff around, but posters and whatnot, because they're gonna be facing that way, right?
Yes.
But I still need to cover everything.
Yep.
Have a good day.
You too.
Testing.
Yeah, ACT will be in here, so I gotta cover up everything that has to do with math.
When do we take the ACT?
Fall.
Tomorrow.
All right, so. I get 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so the cool thing about when you have a slant asymptote with a vertical asymptote, I'm already gonna tell y'all, they're gonna be like these little mini parabolas inside here. So then you're gonna have one down here as well. Okay. So again, I'm trying to expose y'all to all the different ones that you could potentially see. Okay. Any questions on that so far? Okay. I'm gonna do one more. All right, Victor. Do some of these real quick. So all of the math posters have to be covered up. So, with that being said, I might just put you on just the ones above the board. And I'll have someone in my other class do the others. Okay. You don't have to like completely cover it from corner to corner, just enough that majority of it's covered. And then if you want to, and it would probably be the best bet, is when you tape, just tape the 4 corners or even just the top 2 corners. And if you tape them on the poster, they'll stay up.
Yeah.
Okay. Or even the 2 sides. Thank you. So we have not had a horizontal asymptote that has been a tie, so we're doing that one here. And we also haven't had any holes. We're gonna do that here as well. Remember, if it is crossed out as a whole, it's no longer a vertical asymptote, and it's no longer an option for our x-intercepts as well. Alright, so we kind of have an idea of how this one's gonna look. It's gonna go back to the old school ones we were looking at. Okay, so when we draw these, I'm first, and if you can remember, I'm first gonna draw it like nothing's wrong. Okay? I'm just gonna go ahead and just sketch it out. Alright? But I have to remember that I have a hole at 3. So if I have a hole at 3, whenever my graph gets to 3, oops, that was supposed to be small, and it was not. I'm gonna put an actual hole in the graph. Whenever it gets to x equals 3, I'm just gonna draw a hole. Okay. But you've got to remember to come back and do that. If you're just gonna draw it like normal, don't forget to come back and draw the little hole in the graph. Okay? All right. Any questions?